All right, so here we're trying to find intervals on which the function is increasing or decreasing. So we're going to first find our critical numbers. To find our critical numbers, we set our derivative equal to 0 or does not exist. Remember, the does not exist really only applies for denominators. So if you don't have a denominator in your derivative, you're not going to worry about the does not exist condition. So taking the derivative, we will have our 8x is a linear term, so that just goes to the coefficient of 8. The minus 24x cubed, we will simply take 24 times 3. So again, take 24 times 3 to get negative 72x, and then subtract 1 from the exponent to get a squared. The negative 12 is a standalone constant, so that goes to 0. And then the 32x squared will multiply 32 times 2 to get a plus 64x. And again, subtract 1 from the exponent. Now, on the homework, you'll see a lot of these questions, the order of the polynomial is all sorts of off. We have an x squared, x to the first, and a constant. So before I set the derivative equal to 0, I always want to arrange my polynomial from powers high power down to the constant. So what that means is that I would look at arranging it from x squared, x to the first, and then the constant. So this next step is simply going to be rearranging. And so I will have negative 72x squared followed by 64x and then the plus 8. And then this is my derivative. And remember, what we're trying to do is we're trying to get our critical numbers. To get those critical numbers, we need to set this derivative equal to 0. Now, that's going to bring up the question of how do we solve this equation? The easiest thing to do is to look at what is your highest power. So in some examples, when the highest power is 1, you have a linear term or a linear equation and you don't need to factor. But here, when the highest power is 2, that means that it's a quadratic equation. And we need to go through, because of the fact that we have a quadratic, we need to go through our different methods for solving quadratic equations. Now, the good news is in this section, factoring will usually work for us. We usually do not need to do the quadratic formula or anything of that nature. So the go-to method is to factor. Now, remember with factoring, the first thing that we need to think about before any other factoring method is, do we have a GCF? And you'll notice here that we do have a GCF because 72 divides by 8 evenly, 64 divides by 8 evenly, and so your GCF is 8. Now, you have a choice to bring out a negative or not. I always tell students, and I always, just as a general rule of thumb, I like to bring out the negative as part of the GCF. So if the polynomial starts with a negative, I think it's easier for the second factoring step if we bring that negative out. So my first step is there a GCF? And here I do have a GCF of negative 8. So I'm going to take out that negative 8. And again, when I do that, I'm going to simply divide 72 by 8, and that's where this 9 is coming from. And then I'll do this really small below. I'm dividing this by negative 8. I'm dividing this by negative 8, and that term by negative 8. So what will happen is the 64 divided by negative 8 will give me a negative 8x, and then the plus 8 over negative 8 will give us a negative 1 equal to 0. All right. From there, what I then do is I factor these three terms. Now, to factor these three terms, I'm going to take the factors of the first times the last that sum up to the middle. Now, what I like to do is I like to kind of go off to the side and do my scratch work for this factoring. So I have 9x squared minus 8x minus 1. You'll notice that this is not a 1x squared. And because of that, the factoring is going to be more involved. Specifically, I will need to split the middle term. So here's how this is going to work. I'm going to look at the factors of the first times the last. So factors of -9 that add up to -8. Those factors are going to be a -9 and a +1. They would multiply together to give me the -9, and they would add together to give me the -8. Now, once I have that combination, what I do is I split this middle term, -8x, into -9x plus 1x. These first and last terms come straight down. And the reason why I had to do that was because it was not a 1x squared. I needed to split the middle. Now, once I split the middle, I now have 1, 2, 3, 4 terms. And so that is where I am going to go through a grouping process. Now, I always like to write out my grouping process as GCF, what's left over, plus GCF, what's left over. So I'm going to look at my first group and say, what is the GCF of this first group? And that is a 9x. So I divide both of these terms by 9x. That will give us just an x minus, the 9's cross out, the x's cross out, minus 1. Then I look at the GCF for my second group. So for my second group, I have an x minus 1. There's nothing in common there beyond just 1. So my GCF would be a 1. And then again, if I take out a 1, I'm going to be left with x minus 1. So I take out GCFs of each group, and then what's left over is this x minus 1 factor. Now, this was group 1, this was group 2. What is common now to both of those groups is this x minus 1 factor. So I then take out that x minus 1 factor, and then that leaves me with the 9x and the plus 1 as GCFs. So this is my factorization for the second parenthesis, or basically the first parenthesis I have here, that second factor. So I go back to my work here. I really like doing that off to the side because that's a lot of mental energy to go through. So I just kind of do that off to the side. Then I come back and I say, okay, this is -8. And then this factor I was successfully able to factor as x minus 1 and 9x plus 1 is equal to 0. Now that it's factored, I'm simply going to set each factor equal to 0. So I'll have -8 equal to 0, x minus 1 equal to 0, and 9x plus 1 equal to 0. Now, be careful with this first factor. -8 equals 0. There's no x there to solve, so nothing is going to come from that. So basically, you're going to completely ignore that in terms of coming up with a critical number. The x minus 1, I add 1 to both sides, I get x equals 1. And then the 9x plus 1, subtract 1 from both sides, get 9x equals -1, and then divide by 9 to get x equals -1/9. So those are my two critical numbers, the -1/9 and the 1. Those are the critical numbers. And now we'll go into step 2, where we will find our derivative number line to test those critical numbers.